So first, let's recall what a prime is. A prime number is a number whose divisors are only 1 and itself. And in particular, 1 is not a prime number. So let's look at some examples and some counterexamples just to refresh our memories on this. 2 is a prime number because 2 is equal to 1 times 2, and that's the only way we can write it. There's no other way we can break down 2 into multiplication by whole numbers. 3 is a prime number for the same reason. 4 is not a prime number because 4 is equal to 2 times 2. And 2 times 2, it's not 1 times the number, and 1 times itself. So if this was just equal to 1 times 4, it would be a prime number, but because it's equal to 2 times 2 as well, then it's not a prime number. It's called a composite. 5 is a prime number because the only way we can write that is 1 times 5. 6 is not a prime number because we can write that as 2 times 3. 7 is a prime number, right? And I'll do one more. 8 is 2 times 4, so that is composite. So that's not prime, that's not prime, that's not prime. 1 is not prime. So 2, 3, 5, and 7, those are prime. 9 is not prime because we can write that as 3 times 3, and so on. So let's actually use this idea of primes to do some math. So we're going to talk about prime factorization. So let me write that up here. Prime factorization. And what we want to do is use primes as the building blocks of numbers. So what I mean by that is every number can be written as a product of primes, and they can be written in a unique way. And this is such an important fact. We call it the fundamental theorem of algebra. And so let's use this fundamental theorem of algebra, the fact that we can break any number down into a product of primes uniquely to take a number and decompose it, basically. So the first one we'll do 6. And I like using the tree method, I think is what Luhmann calls it. So what we're going to do is we're going to make branches beneath the number, and we're going to do products. So 6 is 2 times 3. Once we get to a prime number, we're going to circle it, and I'll use red. And once we get down to where everything is circled, that's the prime factorization. So here, everything is circled on the bottom row. So 6 is 2 times 3. That is the unique prime factorization for 6. Let's do another. Let's do 12. 12 is 4 times 3. 3 is a prime number, but 4 is not. So we can break down 4. 4 is 2 times 2. And the 2's are a prime number. So we can say 12 is 2 times 2 times 3. Or if, if you recall, 2 times 2 is the same thing as 2 to the power of 2 times 3. And I'm going to prefer using this exponential notation. 2 to the power of 2 meaning 2 times 2. So that is the unique prime factorization of 12. Let's do a few more. we'll do, let's say 24. 24 is 6 times 4. 6 is 2 times 3. 4 is 2 times 2. So 24 is 2 times 3 times 2 times 2. And I'll put the 2's together. 2 times 2 times 2 times 3, which is 2 to the power of 3 times 3. And remember, this exponent does not mean 2 times 3. It means 2 times 2 times 2. 2 times itself 3 times. So, I guess we'll do one more on this. And we'll do an easy one. Let's say 7. 7 is already itself a prime, so it's 1 times 7. So that is the unique factorization of 7, is just 7. Because remember, 1 is not a prime number. Okay, now we're going to talk about the least common multiple. And everywhere you're going to see that abbreviated as LCM. The least common multiple is looking at given two numbers, let's say 6 and 8, what is the smallest number where 6 and 8 divide both? Both 6 and 8 divide that number. So what do I mean by that? Let's check. What is it 6 divides? Well, 6 divides 6, right, because that's 6 times 1. 6 divides 12, that's 6 times 2. 6 divides 18, that's 6 times 3. 6 divides 24, that's 6 times 4. 6 divides 30, 6 times 5, right, and so on. Now 8, we have 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, and so on. And what we're going to do is we're going to start, I like to start at the lowest number and say, okay, is 6 in both lists? No. Is 12 in both lists? No. Is 18 in both lists? No. Is 24 in both lists? Yes, it is. We got a 24 and a 24. So the LCM of 6 and 8 is 24. 24 is the smallest number where 6 divides it and 8 divides it as well. There's a way we can do this with prime factorization. If we look at the prime factorization of 6, that's 2 times 3. And if we look at the prime factorization of 8, that is going to be 2 times 4, which itself is 2 times 2. So what we have is we need a number where 2 and 3 divide it. So we know the number is going to be at least 2 times 3. And it looks like we have a 2 over here. So so these two 2's are going to match. But we have an additional 2 2's over here that's going to have to be in it. So times 2 times 2. And if you multiply that out, that's 24. So 2 different ways to get that. One, doing it from this kind of list method, and then one doing it from these factor trees, the prime factorization. Let's do another one. Let's do the least common multiple of 3 and 9. So this way I'll use the tree method. 3 is just 1 times 3. And then 9, so 3 is already prime. 9 is 3 times 3. So we know that whatever the least common multiple is, it has to have a 3 from this side. So it needs a 3. And then we have an additional 3 over here. So that's 9. So the least common multiple of 3 and 9 is 9. And that makes sense, right? You can't get any smaller than 9, and 3 divides 9, and 9 divides 9. Using our list method, we'll do 3, 6, 9, 12, 15, so on. We got 9, 18, 27, 36, so on. And you can see the smallest number in both is 9. All right, and then there's one more fact I want to mention for this lecture, and then we'll wrap it up. And that is probably something that's not in Lumen, but I think it's interesting. If you know what the greatest common factor is, or the greatest common divisor, what that is whenever we're doing these factor trees, let's do 6 and 8 again. 6, 2 times 3, 8 is 2 times 4, 4 is 2 times 2. The greatest common divisor in this is 2, because it's the thing that's circled that appears in both places. And so the greatest common divisor is 2, and I'll put greatest common divisor of 6 and 8 is 2. The the product of 6 and 8, 6 times 8, is 48. And there's this really cool fact that the GCD of 6 and 8 times the least common multiple of 6 and 8 is going to be 6 times 8. So we have 2 times the least common multiple of 6 and 8 is 48. Multiply both sides by a half, and you get the least common multiple of 6 and 8 is 24, as before. So just another way you can go about doing it if you know what the greatest common divisor is. Okay, I'll wrap it up there, and next time we'll be talking about integers. So this concludes the first module of the course.